Alright, time for another draftphysics.com, debatephysics.com, but can't find anybody do any debating or even commenting in some sort of reasonable way on the actual subjects, which I keep trying to get people to talk about, just because I'm simply stating I don't understand, I don't get you. So Disbar has made a video, I didn't watch it, where he's conceding he made a error in his calculating, he's measuring, but probably is just discounting it as meaningless and just wants to keep claiming I'm way off, blah 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 blah. Yeah, same old crap, without any kind of way to understand what he's asserting is true in the context of hundreds of years of history, that nobody has discovered this fact, blah 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 blah. I can go through all the crap that they've never responded to. So you have a simple experiment here where you're going to take a 5-mass object and you're going to put a 5-mass on it, and you're going to end up with a 10-mass. Okay, and this velocity, let's say, starts with 10, and you'll end up with a 5 velocity here. Okay, simple enough. Totally unreasonable in terms of what they claim happens. The kinetic energy starts off here at, say, 100, and it ends up being 50. Okay, so the KE, you lose half of it. Just doing the experiment, doing it, and you do it, the more perfectly you do it, the more gracefully you do this, you can't do better than 50. You can do worse than losing 50%. But you can't do any better than losing 50%. And you will consume 100% of the momentum, just about. Okay, it's 99. 99% of the momentum is conserved. And their argument is they actually think that when you combine these two masses, you dented things, you made sparks, you made stuff move, you did all kinds of crap. And that's their excuse. How could you do that? How could you dent this without using momentum? How could you knock a piece off and send it into space without using momentum? You can't do any of that without using momentum. Momentum moves things. I mean, get real. You can't see it any other way rationally. Come on. No, that's unfortunate. Yes, this is always such a hassle to get these things just right. Anyway. So, and what if I made this a 10? Okay, so I make this a 10. I'm going to add 10 instead of 5. Now I lose 3/4. 3/4 of the kinetic energy lost, gone, just disappears. And I'm supposed to believe that makes sense. I can just make energy disappear, because it really won't get any hotter. It won't make any more sound. It won't do any of this crap. All right. And I'll still have 99% of the momentum when I'm done. So, yeah, theoretically, I can do it all the way to a really heavy object that barely moves. I'll destroy all the kinetic energy, 99% of the kinetic energy, and I'll still have 99% of the momentum. And so that makes sense to them. So the comparison to that is this idea that you can take a light car, a 5, and you can smash it into a standing still 10. And you have this expectation. It's even better if we make it a 15. Okay, just for the fun of it, because if we make it a 15, then we're going to lose half again. So I crash this in. Okay, this time I'm going to lose half the momentum. So I bang this into this object, and then no, I'm going to gain momentum. Sorry. And what I'll end up with is this goes off in this direction, the 15. Okay, and this with 2/3 of the, I think it's 2/3. And this ends up going with 1/3 of the momentum. Okay, I think those are right numbers. Probably not. I probably made a mistake somewhere. But anyway, this has 150 momentums now. Okay, so let's say I went in with 100. Now I have made more momentum. That's their theory. Because I have 150 going this way, and I'll have 50 momentums going this way. Now this time I have the same kinetic energy, so I didn't lose any kinetic energy. I started with 100. I'm going to end up with 75 kinetic energies going this way, 75%, and 25% going this way. No, that's wrong. Yeah, no, they're subtracting the momentums, but yeah, they're adding the kinetic energies. So yes, so that's correct. So this will have 75 if this was a kinetic energy number, and this will have 25. That would be their theory. And again, just saying, logically you can make sense out of this, that now you can make free momentum. So you can destroy kinetic energy, or you can make free momentum. And all you have to do is these silly little experiments. You just bang these things. Oh, Jesus. I got to change the size of that, I guess, or something. Because this is silly. Yeah. Anyway. So, yeah, again, so the argument is that, you know, you can just keep saying, well, how big can I make this? And then I'll get a full extra 2 in terms of free momentums. You know, I'll get all the way up to 2. So I'll have 100%. I can get 200% of what I started with. So I can go in with 100 and I can make 200. Well, in this case, I'm already making 200. I guess I can make 400. Anyway, sorry, I'm just not going to do the video over. You get the, I think we've been over it so many times, you get the idea. It's free momentum because direction really doesn't matter. You can't take the 50 going this way in momentum and say, I'm going to subtract that from this and say somehow these aren't real mass moving. I mean, mass moving is what the universe runs on. It doesn't run on something else. Anyway, so the point I was going to make, so let's say you redid this Newton's cradle thing. Okay. I mean, you know, it just doesn't, you're just saying, okay, what's the logical thing? You know, how can you make it make sense? And I'm just saying I can't make it make sense. So until somebody can tell me how it can make sense, I'm going to say shenanigans. I'm going to say you're fucking up somewhere. Like Professor Lewin, you got clay on your card. You're doing something wrong. Alright, so we're going to swing the light thing into this heavy thing. And the idea that we're going to get this extra momentum now. Okay, this goes in with a 100 momentum. I'm going to get 150 going this way. This is a 3 mass. 1 mass. And I'm going to get 100 back this way. I mean 50 back this way. Okay, that's what the momentum's going to do, and you can just do the calculations for the kinetic energy. It will be conserved. Okay, because this is going fast, and these two things will be going some percentage slower. So, but if I put if I just leave this alone, and I just put a little ball right there. Okay, I put a 1 mass in. I put a 1 mass in, I'll hit the 3 mass. The 3 mass will send the energy into the 1 mass, and I'll get I'll get 100 here. I'll get no free momentum. That'll happen. I mean, he can try that experiment, but that'll happen. You put this in, it'll go right through this, and it'll just send that off with 100. But if it doesn't hit it, if I move this just a little tiny bit away, so it's not going to be able to do that transition, then the 3 mass will collect 150 momentums. It'll hit the 1 mass with 150. But it's not going to be able to send it all the way back because it's going to reflect. Will have to be the answer, right? I mean, what other answer can there be? Well, it can't reflect because it's heavier. All right, so it has to just keep going. So if I leave a little air gap, so this is the part that gets tricky. So if there's no gap and the two things are sitting next to each other, all I get is this flies off of this end, and it comes back, hits this, and this one flies back up, and these two things just fly back with 100. But if I leave a gap, okay, so if I put a gap here, and so this one has to first absorb the energy. What then is going to happen is this one's going to reflect here with 50. This one's going to move forward with 150. Then it's going to hit this one. Okay, and it's going to move it forward with some amount. I don't know the answer to this one. And it's going to keep going this way to add up to the 150. So this big thing is going to hit the little thing. The little thing is going to move, and the big thing is going to keep moving because obviously it's bigger. Bigger things don't reflect off smaller things. Smaller things reflect off bigger things. So just play this out for me. What do you, you know, so what we need is another, you know, we just need another one of these lighter objects, and we can do this simple experiment and figure out whether this can make any sense at all. Then I'm actually going to get more energy, right? I'm just going to get this 100 momentums back if I do this touching. If it's not touching, then I've converted it to 150. I'm going to hit this little thing. It's going to go off with some percentage of that 150, and this is going to continue going on with the other percentage. So what's going to be 75, 75? Is that what we're predicting? You know, so this will keep moving, and this will go 75% of that 100. Is that going to be the number? Yeah, I mean, is that going to be the theory that they're both going to go? So I'm actually going to be making the free momentum real visual, in the sense that both things will be going in the same direction. There won't be any reflection this time, right? So this will come in, collide with the 3 mass. Oh, that's right, we did get a reflection, but it doesn't matter because we still sent 150 forward, so it won't matter if there's a reflection. Because now we've increased the energy. We'll have 50 more, you know, 50 plus will be hitting this. Okay, so we'll have 150 hitting this, and they're both going to go in the same direction. So I'll have converted the extra momentum they're claiming. I'll have at least converted the 150 part into clearly something moving in one single direction in 2 objects. I'm just saying, I mean, you can just keep doing this, right? You can keep colliding these things into things and making free energy, right? Because I could just collide this thing into a big thing again, the little one, and make some more free momentum. And then I could take the big thing that's still moving. Well, and I can't crash that into, I could crash into a bigger thing, but that's going to be tedious. I just mean, it just doesn't make any sense. One of these things is the real thing, okay? It's either momentum. You either got to believe that momentum, mv, which Newton, Galileo, and Descartes observed to be energy in the universe, is the right answer. That's what makes energy in the universe. You just take a mass, whether it's an electron or whether it's an elephant, you know, it just doesn't matter what you use. It doesn't matter which one, okay? Mass moving, that's all there was. And that this mv squared stuff, it's either, like I said, one of them has to go, because both of them can't be right. And I'm just saying, I don't even understand how the kinetic energy thing has any viability at all when it's breaking the creation and destruction rules. Because it's clearly in the other experiment, you know, when I'm doing the make the light thing heavy, okay, when I do that experiment, I lose half the energy without there really being any explanation for how I lost half the energy. So anyway, that's an inarticulate example of explaining, but that's where we are. And so I'm confident, all right, that there's something wrong, okay? If you're going to say you can make free momentum, or you're going to say you can destroy kinetic energy, I'm going to say something's wrong. Now, maybe you're not going to say that, but I'm going to say it. That, you know, all of this stuff is a little bit delicate and sensitive, and you have to be careful how you do these measurements and all this crap. But does it really make sense to you that you can destroy kinetic energy really easily, and that you can make free momentum really easily? It doesn't make any sense to me.